Welcome to the part 7 on plant pest survey planning. Here we are going to explain some technical information needed in designing and drafting an annual survey plan, especially how to prepare it for the implementation. This includes consultation with risk assessors and survey providers. This tutorial may assist a risk manager officer at headquarters of competent authority who wants to optimize an overview planning table with risk-based priorities. The aim is to combine rotating quarantine pests in annual survey so that the available budget for this year can be properly divided for the implementation. In this video, we will present the ranking of priority actions considering the risk. We will focus on optimization of survey plans to risk areas and to the breakdown of inspection and sampling to appropriate field survey sites. As every competent authority has limited resources in terms of financial and human capacities, phytosanitary actions have to be focused on high-risk pests and locations. In setting priorities for action, we use a simplified matrix for pest risk ranking. Risk is defined as the product of the likelihood of quarantine pest entry, establishment, and spread, as well as its potential impact or consequences for a new pest entry, establishment, and spread in plant production, natural growth, landscape, the environment, society, and other relevant sectors. If the likelihood is high and impact extremely high, the risk will be extreme, and the pest will be in our first priority for actions. If due to ecoclimatic conditions the impact is expected to be moderate, also the risk is moderate, and the pest will be ranked into second priority for action. If the host plants do not grow naturally or the pest will not survive the winter, the impact will be very low or negligible, so the pest will not be selected for monitoring but for the exclusion from the official surveys. In the project, we supported Western Balkan countries in their preparedness for surveillance, which they are already organizing. Here you can see the list of their priorities. The pests which have been already under the official surveys since 2022 or earlier, those are shown with brown bars. In gray you can see the year 2025, and in blue are the planned priorities for the next years. Among the plant quarantine pests are some priority pests of the European Union affecting forests and parks like pinewood nematode, emerald ash borer, and Siberian conifer silk moth. Also, some citrus pests are not yet addressed in some countries, like black spot of citrus and some fruit flies. In countries where they do not grow citrus plants at all, they may justify that the Philostigta citricarpa will not be actively surveyed, but it will be justified as an exclusion. During the project, we supported beneficiaries in developing technical material for selected top 10 pests. Namely, we developed survey protocols, summarized safe sampling protocols, gave advice for survey data collection and reporting, and collected promotion material for communication with public and the stakeholders. For 6 priority pests, we developed contingency plans, and for some emerging pests, we developed eradication programs, which both raise preparedness for the case of an outbreak. We also developed guidelines for eradication of new, not yet listed pests, such as forest ant caterpillar, which have quarantine characteristics. Such technical documentation is needed in developing the survey protocols, where we need to consider the risk factors which contribute to entry and establishment of new pest species. For example, this is an import of fruits and plants, hobby growing of plants, infested packing material, and so on. Then we need to identify the risk locations where those activities take place, such as storage places of imported fruits, processing and fruit waste disposal places, border points of entry, packing stations and places where import fruits are traded, and so on. And in the third step, we would like to know where those hotspots could be located. Where are the risk areas where the risk of introduction of quarantine pest is high or moderate, to monitor plants there or to put traps for pests there, like for fruit flies trapping. In answering the question where the hotspots could be located, where are the risk areas, competent authorities appreciate support of geographic information system experts who can access the geospatial databases and operate with GIS tools to visualize and analyze the locations of our interest. We got help from North Macedonian GIS expert Professor Dr. Duško Mukajetov, who prepared the inventory of host plants in official use for agriculture sector, forestry, urban areas, natural areas like parks and protected areas, and prepared some examples of demarcation. Geographical analysis and visualization is essential for survey planning. In detection surveys, we will identify spatial locations of host plants and epidemiological units. And in case of an outbreak and need for delimiting surveys, we will need maps of established infested and buffer zones. First, plant health authorities need to get access to the geodatabases of the ministry responsible for National Farmers Registry System in supporting agricultural subsidies. Here is an example of land parcels visualization from Kosovo. Besides the map, there are very useful data about the acreage and crops on the farmland. Second example is from Montenegro, where on the top of farm registry, there is a registry of vineyards and other permanent crops. The next example is an inventory of Ministry of Serbia, responsible for environmental protected areas. So in eventual demarcation, we would know about special canopy and protection of plants there. Also, the municipalities have very useful official registers for our use when we need to survey parks and other plants in urban areas. The local geodatabases here, first one is the Green Cadastre of City of Skopje. We see graphical data and attributed database. The second example is Green Cadastre of City of Bitola in North Macedonia. We see the map of the green canopy there. For pest-specific surveys of grapevine, we can prepare hotspot areas for monitoring based on farm registry data. Our resources can be focused to the most intensive areas, and at the same time we can plan for all regions with vineyards certain number of survey sites. In case of a need to make a buffer zones around the vineyards, this could be done. For example, 150 meters or 450 meters around the vineyards, depending on the pest biology. And then we can calculate the acreage for the survey. Some quarantine pests spread along the highways and roads, such as Popillia japonica or Xylella fastidiosa. With GIS analysis, a GIS expert can prepare a map with crossing layers of infrastructure and forest canopy of acer, ulmus, quercus, and other host trees. Roads, and especially rest stops along the roads, are known hotspots for many invading quarantine pests, which first attack the edges of forest, grasslands around, and urban areas or parks, which we need to survey. If plant protection services do not yet have the access to farm registry and to other official geodatabases and GIS software tools, they can provisionally plan their hotspots for survey in the European platform for land cover. Corina land cover can be a first help in planning of surveys and mapping the demarcated areas, as we used it for one of the simulation exercises. For the beneficiaries from Western Balkans, we prepared a map with real monitoring sites for Spodoptera frugiperda, and we simulated the positive findings at two locations, one in maize field and the other on the rice field. At the next step, a demarcated area was drawn on the map for intensification of field surveys in the surrounding risk areas. Not only for demarcated areas, but also for surveys of certain risk area, the GIS expert can prepare maps for field inspection to target properly the risk locations and plants growing there. If the competent authority does not yet have access to national geodatabases, then would could the land cover map serve for mapping the areas and results of surveys. Last but not least, when all the risk areas and survey sites for selected pests in annual survey are identified, a breakdown shall be done to regional units, at least a number of survey sites for visual inspection or for trapping, and recommended timing per each pest or pest group should be done if surveys are done in the crop-based approach. Here we have for longhorn beetles the timing of the whole year around, but inspectors then know that they go to inspect growing plants during the growing season, while some of the risk areas they could do inspections during the winter time when eventual exit holes from trunks of the trees would be visible. In case of trapping the adult insects, the timing is defined appropriately to the life cycle. When the flying beetles or moths are emerged, they mature feet and copulate for new generation. This is June to September for Japanese beetle and August to October for Spodoptera frugiperda. This is different for every pest. The feasibility of implementation of such plan is then checked during the consultation period, when such plans are distributed to organizations which are involved in surveying, to inspectors and experts at institutes or other organizations. With all this preparation, we are now ready for the implementation. If the maps can be produced as a part of survey planning to enable targeted implementation, then using of official borders is recommended. In the EU, we use statistical regions and units. The recommended level is NUTS level 2. See our next video on plant pest survey planning and reporting for details.